In this tutorial, we will describe the conditions and the products of catalytic cracking. The name of the process can give you a hint as well. Catalytic means that a catalyst will be used. So catalytic cracking takes place at a lower temperature than thermal cracking, which is approximately 720 Kelvin, and at a lower pressure, but of course the pressure will not be lower than the atmospheric pressure. Catalytic cracking takes place using a zeolite catalyst, which consists of silicon dioxide and aluminum oxide, so it is called aluminosilicates. Zeolites have a honeycomb structure with an enormous surface area. So because we have an enormous surface area, this will allow the reaction to take place. And they are also acidic. This form of cracking is used mainly to produce motor fuels. And the products are mostly branched alkanes, cycloalkanes, which are rings, and aromatic compounds. Aromatic compounds are based on the benzene ring C6H6. So we have 6 carbon atoms which form a ring, and we have 3 double bonds. So this is a benzene ring. Aromatic compounds are compounds which are based on this benzene ring. So because the products of catalytic cracking are branched alkanes, cycloalkanes, and aromatic compounds, these products need to be separated, and this is done by fractional distillation. In the lab, catalytic cracking can be conducted using this apparatus. And in this case, lumps of aluminum oxide will be used as a catalyst. So the catalyst will be aluminum oxide. So in this tube, we will have some mineral wool which will be soaked with paraffin oil, and this is a saturated hydrocarbon. So at the bottom of this tube, we will have mineral wool which is soaked with paraffin oil, and this is a saturated hydrocarbon. It is a mixture of alkanes where we may have 10 to 20 carbon atoms. This is unglazed porcelain. So this is the aluminum oxide catalyst. And then this tube will be heated, which is closed of course. And the vapor will pass, and mainly we will collect ethene gas. So the products will mostly be gases, showing that they have a chain lengths of less than 5 carbon atoms. Remember that chains having less than 5 carbon atoms are most likely to be gases. And this mixture decolorizes bromine solutions. So if it is added to a brown bromine solution, the color of the bromine solution will disappear. And this is a test for a carbon-carbon double bond, showing that the product contains alkenes. So when alkenes are added to bromine solution, the bromine solution will decolorize, so we have a double bond. For example, we may have octadecane, which is a saturated hydrocarbon, and the product will be ethene. So this is an alkene. So saturated means that we have alkanes or the bonds are single, whereas unsaturated means that we have double or triple bonds. So the products will be C2H4 plus C8H16 plus C8H18. So a longer chain of alkanes after cracking will produce shorter chains of unsaturated hydrocarbons and of saturated hydrocarbons as well.